Yeah.
I'm going to take the test today after school. Can I get these to you tomorrow so I can? They're the reviews.
Of course.
Okay.
Of course. Yeah. All right, guys. So today we are starting probability. And I know some of you have mentioned this to me in emails or conversations that I'm getting killed on my ACT. Maybe not killed, but I'm losing possible points on my ACT. Hopefully this will remedy that because we will do way more in probability than you ever need on your ACT. I teach this kind of at a math team level, and I'll be honest with you, by the time we get done with this, you should be pretty strong. This is not what you would normally learn in a pre-calc class. This is what you'd learn to do well at a math tournament on probability. And honestly, this will probably get you 2/3 through a probability class in college. Believe it or not, we really tackle some tough concepts, and the pace that we go on is typically a little bit faster than you would experience probably in a college math class, maybe not a graduate math class, but we do tend to move kind of quickly. So I think you'll get a lot out of this. I think it will help you on your ACT or PSAT or whatever, but let's just jump into it. I gave you a packet. This was actually what we did in Algebra 2 most years. And again, instead of taking a 5-day, normally we do probability 1, 2, 3 review test, and that's it. And it basically we're regurgitating what we learned in Algebra 2, really nothing new, maybe nothing new. So we're just going to go through it like the regular Algebra 2. You have in the book probability 1, 2, and 3, and maybe a review. Maybe, I'm not sure what you have in the book if you want to pull that out, but you don't have any of the lead into it. So what I did is I gave you that little packet. And it's not numbered because I had to pull it out of Algebra 2 and kind of reformat and tweak it for this class. So you could just put that in, and you'll notice on the assignment sheet, it's really kind of vague what we're doing. It says something like, all right, we're going to start moving through counting principles. And I know you know how to count. We're talking about counting quantities like, you've given these Tyree problems like how many ways can you arrange the letters in the word Mississippi uniquely? And you've probably seen that in before, maybe in Algebra 1. Well, look at some of those kind of things. Well, you are counting the number of ways. So that's the kind of counting I'm talking about. And you need to be able to count because the whole idea of probability is saying how many ways can you be successful over the ways that you can be successful and unsuccessful. It's kind of like if I said, what's the probability of being a king? Well, there are 4, if you pick a card from a deck of cards, right? Well, there are 4 ways to be successful, but there are 4 ways to be successful and 48 ways to be unsuccessful, or 52 total ways. So probability counts the number of ways you can do something correctly or do something that you're looking to do over the ways you can do it right or wrong. So to be able to do that, we've got to be able to count. So we're going to spend a few days. Notice when you look at the homework again, it's not going to say finish worksheet, whatever. What I'm probably going to do, you probably honestly won't have a ton of homework, but I'm going to be just randomly going through the problems. Whatever I skip, it's your job to go back and make sure you fill in the blanks and get those other ones either done and understood or come in here with good questions. All right. So make sure you do that. Also have good questions in here so that you'll understand this well. And because it can get kind of tricky at the end. Most people, and let me just caution you ahead of time, most people kind of have that feeling of, oh my Lord, what's going on? Their head's going to spin a little bit. And then after some repetition, you're going to kind of start sorting things out mentally. And if you continue to work with me, you'll sort things out mentally and you'll start to get some confidence with it. Because we're going to do, you can see how many review sheets. I mean, good night. Look at this. After we finish probability part 3, we have the review probability and counting worksheet. Then we have the probability and counting worksheet. Then we have the probability worksheet. So that's 3 full days of reviewing this over and over and over before we finally have our test on Wednesday the 24th. Are you with me? So it will come together if you trust yourself and stay with me and ask good questions and it'll help me to think how you're thinking because everybody's brain works a little bit differently, especially with this probability. And the more I can troubleshoot and kind of fill in the gaps in the way you're processing, the better off we're going to be. All right? Okay, so if you jump to this, okay, where are we? I have this somewhere. This is not in your book, so. Yes. All right, so let's just start taking a look at this, and I'm going to start you out with a definition of probability, but then I'm going to start jumping in. We're going to forget the probability, and I'm going to look at probability for a few days, and we're going to talk about different ways to count things. And some of you are going to naturally think this way, and some of you are going to have to really go back to your formulas and your understanding of factorials, things like that, combinations, permutations. But anyway, we'll get there eventually. So I wanted to throw out the definition of probability and maybe show you some different terms that are used. So probability, there's a number of definitions, but one of them is, and this is the probability of an event occurring. Now, an event is not like me rolling the dice. An event would be like me rolling a die and getting a 3. Okay, so that would be the event. So if I say, what's the probability of an event occurring? Like, what's the probability that you get a 3? It would be the number of ways you could get a 3. So if I roll a die, how many ways can you get a 3? Just once, right? So you counted that up. Over the number of ways I could succeed or fail. If I roll a die, how many ways could you get a 3 or not a 3? 6. And that's a very basic way to look at probability, but that would be 1/6. So there's a 1/6 chance you would get that. Now, I know you don't have to think about that when you're doing rolling a die and I say, what's the probability of getting a 3? But if I start asking you things like, all right, what's the probability if you roll 3 die that the sum is 15? Well, now there's a lot of different ways you could get 15, right? You get a couple 6s and a 3. You could get 3 5s. You could get a 6 and a 5 and a 2. And you would have to count up the number of ways that you could succeed. And then you'd have to count up the number of ways you could succeed or fail, which honestly is a little bit easier sometimes in the denominator. Because, does anybody know that? How many ways I could succeed or fail if I'm rolling 3 die? Anybody got a guess?
6 cubed.
6 cubed? Well, he said 6 times 6 times 6. Sorry to go a little creepy there, but that's our fundamental counting principle. So the first thing I want to jump into is leave that probability a second. Let's talk about counting things up. So the fundamental counting principle talks about, and it starts with just 2 different events, but it could be 3, like the rolling of 3 different die. If you have 2 different events, and the first event, and again, an event would be something that we're actually doing, right? Something that we're trying to achieve or whatever. Event A, it says, can occur m different ways. Event A, after it's occurred, event B can occur in n ways. So you got 2 different things that occur 2 different ways. Okay? And I probably should have put experiment in there instead of event, but go with me. All right? It says the number of ways that the 2 can both occur. All right? Can both occur is just m by n. So for instance, if I roll 1 die and there's 6 ways it can occur, right? And I flip a coin and there's 2 ways that it can occur, then how many different outcomes can I get flipping coins and rolling die? 6 times 2 is 12. Because I could get a 1 with a head, a 2 with a head, a 3 with a head, a 4, 5, a 6 with a head. And I could get a 1 with the tail, a 2 with the tail. So I've counted those up by going 6 times 2. So when Spencer said 6 cubed, the number of ways, when we're rolling 3 different die, that's 6 ways times 6 ways times 6 ways, right? That I could actually succeed or fail. All right, now it's a little bit harder to figure out how many ways I could get a 15 if I'm summing those results. And sometimes we can use a formula or some kind of thinking for that. And sometimes we just have to start writing them out, right? I could get a 6 and a 6 and a 3. I could get a 6 and a 5 and a 2 or whatever. And I'd have to start thinking 6 and a 5 and whatever, a 4. I have to start thinking about those outcomes. So sometimes it's a little easy, sometimes it's not so easy, but we're going to start processing through that step. So I just want to start throwing problems at you, and I want you to think about the fundamental principle when you can. And remember, the questions for today, probably tomorrow and the next day, are not about probability. We're just counting different ways to get stuff and trying to explore and think about how to do that efficiently. So how about this? English alphabet's in play. How many ways can 2 letters be chosen? Oh, and by the way, do y'all know the difference between replacement and non-replacement? So like if I'm playing cards and I got a deck of cards, right? And I'm drawing a hand to play spades or hearts or poker or whatever. I don't draw a card, look at it, and put it back in the deck, do I? If I did, and there might be a game like that, that would be with replacement, okay? Yeah, so if I draw a card, I'm keeping it. So the first card I draw, let's just say I draw an ace of spades, right? Now, my next draw has the probability of drawing an ace changed? Yeah. Have the number of ways I can draw an ace now changed? Right. So in a problem where what happens affects the next choice, 2 things are in play. One, if I take it and I keep it, I've kept it. That's different than if I've replaced it. So if you see the word replacement, it means whatever you're doing, you're putting back. Now, some things have a natural replacement. They won't even say that, like rolling a die. If I roll a die and I get a 5, does that mean on the next roll, 5s are off limits? No, there's always going to be a 5 on one of the faces, right? So it's kind of got a built-in replacement property to it. So sometimes you don't have to say with replacement, but sometimes you might. So be aware of that as well. And then also 2 words, which I'll go over later, dependent and independent. Okay, so for instance, say you're counting the number of ways you can get a king, right? So how many ways can I get a king on a first draw? Does everybody here know about cards? Don't be shy. See, that's a big deal. If you don't, I want to just kind of walk you through that real quickly. Everybody knows that there are 13 different kinds of cards, and the difference between a kind and a suit, if you play poker, you've gotten 3 of a kind. 3 of a kind doesn't mean 3 hearts. 3 of a kind would mean like 3 2s or 3 aces or 3 kings or 3 jacks, right? And then of those 13 kinds that go 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, ace, right? Of those 13, there are 4 suits. And the suits are the hearts, the clubs, the diamonds, and the spades. And each kind has 4 suits. Are you with me? Okay, so if I ever say 3 of a kind, I don't mean 3 hearts, right? I would say 3 of the same suit if I meant that. Okay, well, if I draw a king, right, and I keep it, has the next probability of drawing a king changed? Okay, we would say that is a dependent event because the next draw's probability or number of ways you could count it depends on what I drew the first time. Like if I reached in there and pulled out a king, then now the number of ways to draw a king on the second draw would now be 3, right? But if I reached in there and pulled out a 10, the number of ways to draw would still be 4, but the number of ways to draw a 10 would be different, wouldn't it? Right? So if I pull something out and it changes the way I count, that would be a dependent situation. Now, an independent situation is kind of what it sounds like. If I'm rolling a die and I roll a 6, did that affect any of the next roll? No, the next roll is independent of what happened the first time. Right? It doesn't have any consequence what I roll. In fact, in Vegas, if you go to Vegas, like or Jersey or whatever, a lot of times they play roulette. Now, roulette to me seems kind of boring, but actually roulette in most places is the best chance you have of actually winning. It may be a little boring, and although it might be exciting if you hit it, but you're just spinning a wheel and you're looking at it and you're like, there's no skill involved here. That may be true. But actually, there's the closest probability for you winning is on a roulette wheel because they have like all the reds and all the blacks, and then they have like a couple of greens in there. And all that does is give the house a slight edge. And that's all they need, right? They've got really nice places in Vegas, and they're not there because you win, all right? They're there because you lose. But if you really wanted to stay in Vegas and lose your money as slowly as possibly, that would be your best bet. But you know what they have at these roulette? And by the way, roulette's where you just spin it, right? You bet on like a red or a black or a green or maybe a 4 or a jack or whatever. You bet on that, put your money down, they spin it, and the little wheel spins around, and then it just drops in the slot. And if it matches, you win. Well, they actually have these little towers. They're little lit up towers, and they show the last 7 or 8 plays or spins in roulette. Why would they do that? That's right, to make it seem like some people are suckers or superstitious, and they walk up and they're like, oh man, look, it's gone red, 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 black, red, red, red. It's done red so many times. No way it's hitting red again. But it's roulette, right? All those rolls are what? Dependent or independent? Independent of the next one. They have nothing to do with that. But psychologically, they kind of lure suckers in there. And if you're going to Vegas, honestly, if you're going to Vegas just to have some fun, go to Vegas and have some fun. I took my kids, not to like corrupt them, but I wanted them to see it. I took them and we went to the MGM and the Caesars and we looked around and, we stayed at a hotel and had a good time or whatever. And then I took them to old Vegas. I went to old crappy Vegas and let them see how depraved it is and just how rough it is. A little story. I went on a big road trip with a friend of mine back in like 93 or 94, and we went through Vegas. And I remember driving into Vegas, all these signs, and it's a little bit different now. It used to be you could go to Vegas and it was like, filet mignon dinner, $5.99. All you can eat lobster buffet, $5.99, $5.99. It's like, you gotta be kidding me. Stay at the MGM, $39.99 a night. You're like, this is awesome. And it used to be like that. Now it's kind of geared more to the family, but it used to be, we'll give you everything free just to get you in the door because we know we're going to get it back. Right? But I remember that night we stayed somewhere and I was out just my friend got tired and I was like, I'm just going to go walk around and see what's there. So I was walking around and I remember going into this this is 93. So this is before New Vegas. This is when old Vegas was still kind of hanging in there. And I remember walking in this old crappy place. Like smoke, back before they banned smoking in public places. The smoke was like, hanging down from the ceiling. It felt like you had to part your way through it. And I remember some woman sitting and she had like curlers in her hair and she had her mouth just tightly wrapped around this little cigarette. She was all wrinkled up and she's got her little cup of coins and she's playing the slots. It's like 2 a.m. and she's playing the slots and it's a penny slot machine, like penny, where the grandmother prize is $20. At 2 a.m, this person's playing penny slots for the 1 in a million shot of winning $20 at 2 a.m. in curlers. And I was like, that's enough for me, man. Vegas is just, if you're going there for the shows and the entertainment, but when I saw that, it really put an imprint in my brain what gambling can do to you. So if you're gambling for, I'm getting off a little speech right here, but if you're going there for fun, I guess, have fun, because I know a lot of people are like, go to Vegas, whatever. But if you really feel like you're gambling for your power bill or to pay your car payment, you need to get help. Seriously, because I had a friend who lost it in college, started vanishing and disappearing, and we found out he was going to Mississippi, like leaving Auburn to drive to Mississippi to gamble. And some guy knocked on our door once looking for Joel, and this is a big thumb breaker, trying to collect I don't know what it was, $4 or $5 grand that he owed him. It gets really scary when you start going down that path. So strongly discourage that. But for whatever that's worth, let's just jump into here and see what happens with some counting principles.
Unless you're like a poker shark and you can make bank.
Well, here's the thing about that, and then I'll stop. Probably the most successful, one of the more successful guys is a guy named Phil. Phil Ives is really good too. What's the poker brat? What's his name? What's his name?
Phil
Hellmuth, yes. So he's so annoying, but brilliant poker player, right? And actually, Ivy said the same thing. But they'll say, yeah, I've been bankrupt 2 or 3 times. Like bankrupt, mortgage the house, bankrupt. Or maybe even in debt, like maybe underwater, a couple $100 grand. And they're like, we're just not afraid of that because we figure, poker goes in swings sometimes and we'll get it back. And most of those guys now, especially Hellmuth, have written books. They do seminars where people pay a couple $1,000 and they show them how to play poker, and they make their money that way, and they get sponsors to pay their fees. So now they're just kind of rolling along. But again, if you find yourself at a poker table and you look around and you don't see the sucker in the first 10 minutes, it's you, right? So there's always somebody who appears like they don't know what they're doing, that really does know what they're doing, waiting to take your money. I don't know that it's a lifestyle. Like, I don't want to be a hero. Like, I like to pay my bills. I like to know that everything's taken care of. Living like that, it's risky and it's exciting. You know, it's like those thrill seekers that like jumping off cliffs and whatever. But I would be really careful with that. Play with your buddies. I love a good game of Omaha 8 or Texas Hold'em or whatever with my friends. And but I know at the end of the day, the worst case scenario is I'm out 60, 100. And actually, I look around the table and I'm not the sucker. So I normally am leaving with their money, which is not a problem.
Sorry, can you count cards?
No, and you won't either into a 6-bet shoot at Vegas. You won't. And here's the thing. It's not about you counting cards. So if you've seen movies like 21, I have an uncle that was a really good count carder, and he would go to places in Nevada, and he would count cards. He'd find tables that dealt out of a 1-deck shoot, so it was only 52 cards. But here's the thing. The guys are trained. So counting cards is about putting down $1 bets until you see it in your favor, right? You see the cards in your favor, and then you put $10 bets down. Well, the guys in Vegas are just trained. They know what everybody's bet is for the last 10 hands. So if they see somebody going 5, 5, 5, 5, 5, and all of a sudden they throw out 50, guess what they do?
Yeah.
No, they could. They still want their money. They just take the cards, dump them down, get a new shoot, and your advantage is over. So count. It's the bet that alerts them. So, and he said that he was at a table in Laughlin, Nevada, in the middle of nowhere, in a little dumpy place playing $1 poker, and he's putting dollar, dollar, dollar. And the second the cards get in his favor, he put a 20 out, and literally he put the 20 out, and within 5 seconds he heard on the speaker, "Counter on 8," and he goes, and he looks up and he's at table 8. Nobody's there, and the guy just goes, pops the deck, gets a new deck out, starts dealing again. There's no way to beat Vegas unless you're cheating. And if you're cheating, if you watch 21, you see what happens to cheaters. Yeah. There are cameras everywhere in Vegas, except a couple of rooms down in the basement. Yeah. You don't want to be in one of those rooms. All right, so here we go. How many ways, we're counting, can 2 letters be chosen from the English alphabet, A through Z, right, with replacement? So we're counting, okay? So how many ways can 2 letters, if I'm replacing them? So fundamental counting principle says we're doing 2 different things. I count the number of ways to do the first one, the number of ways to do the second one, and I multiply them together. That's the fundamental counting principle, right? And you got to remember the word "and" has to be in there. So I'm doing this event and this event. Now, if the thing says this event or this event, you're doing one or the other. That's different from doing 2 things. I am doing 2 things here, right? I am picking a card and then I'm picking another card. So with replacement, how many different letters can I choose on my first choice? 26. I put it back. How many different letters can I choose on my second choice? 26. And because I'm doing both of these, I'm picking a letter and I'm picking another letter. 26 times 26. And by the way, I do not need you to multiply this stuff out. And that's true with all the probability we do. Don't even bother. Okay, I don't even know if my keys, maybe early on it might have it multiplied out. I do not care. On a test, you are very rarely, if ever, going to be asked to multiply anything out. All right, what if I don't replace the letters? No replacement means when I take it, it's no longer an option. So once I pick that first letter, which how many ways can I do that? How many ways can I do the second letter? 25. Okay? How about this? How many telephone numbers can be assigned to each area code if the first number after the area code can't be a 0 or a 1? So let's just say hypothetically we have a certain area code like 334 or 205. That's not on the table. Doesn't say how many different numbers, including area codes. So we're just saying for a particular area code, the first number. Now, how many numbers does a telephone number have? 7, right? Like your phone number is blah, 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 dash, blah, 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 blah. So of those options, how many numbers? The first number can't be a 0 or a 1. So how many options do you have? Just 8? But after that, does it specify anything? So how many different options do I have on the remaining 6 choices? 10? 0 through 9, right? So each of these other options, I have 10 choices. But on that first one, it couldn't be a 0 or 1. So whatever that gives me, 4, 5, 6, 8 million different phone numbers for each area code that I can have, right? All right, no replacement. If I don't replace them, that's basically saying once I pick a number, I can't use it again. So if I think about it, let's be careful on this one. How many on the first choice? 8. Now, once I pick that, whatever it is, a 0 or 1, it's not an option. So how many more options do I have for the next choice? I have 9 options still available, right? Now, once I pick that one, what do I have? Now 2 have been chosen, right? So now I have 8. And once I pick that one, I now have 7, and then 6, and then 5, and then 4. Because every time I pick a choice, that's one less number that's available, which is not how we do phone numbers, but anyway. Are y'all with me? And if you see these factorials happening, if you want to write 8 times 9, well, we'll talk about permutations a little bit later, how you can say that this is really 9p6. I'll show you, because you're basically saying I'm choosing the first 6 numbers in 9 factorial. That's what 9p6 will be. But I know we haven't talked about those. It's not something we have done a lot from last year. All right, how about this? 8 pieces of paper are numbered from 1 to 8. 8 pieces of paper are numbered from 1 to 8. 2 are drawn with replacement. How many different ways can a sum of 12 be obtained? So you're picking 2, but you're replacing it, right? Each time. So every number is still an option. How many ways can you get a sum of 12? So I could pick a, what? Okay, I could pick a 6, put it back, pick the 6 again. All right, so that's one way. I'm going to just write them out, and then I'm going to count them. What else could happen? I need a sum of 12.
8 and 4.
I could get I heard 7 and a 5, and I've heard 8 and a 4. Now, I could pick a 7 first and then a 5, but could I also pick a 5 and then a 7? Is that a different way? Looks like it to me. And along with that, 8 and 4, or 4 and then 8. Anything else? Nope. So how many ways were you able to do that? And you can see, by the way, don't say, well, I could get a 6 and a 6 or a 6 and a 6. No, you can just get a 6, put it back, and then get a 6. That's different than going 8, 4, 4, 8, right? So don't count that twice. So sometimes we're going to have to count very methodically, and there might not be a great way to figure that out. Sometimes we'll have a better plan to figure it out. How about this? License plates. Can you have for Jefferson County? So in Jefferson County, I don't know if you know that, but the first digit is a 1, right? You guys live in Jefferson County. Now, some of you guys have license plates that start with 58, like I do, because your parents own a house or they own some property in Shelby County. And if you happen to own like 1 acre, you could literally register and make a little LLC. You can register your cars to that acre and pay a whole lot less on your car insurance. On your car tag. Like my car in Shelby County for an old truck I have is, I think, $18 a year. But if I go here in Birmingham or Jefferson County, it's 4 times that, right? If I have a tax on my wife's Sequoia, it might be $300 here. Well, it might be $750 in Shelby County. So sometimes just the car tags, it's nice if you happen to have a little something somewhere else. Or some of you might have a property like at Lake Martin or Smith Lake, where everything's cheaper up in Coleman County or whatever. So sometimes you'll have license plates that don't start with 1, but if you're just a normal human being that lives in Jefferson County, all your plates start with 1. So for Jefferson County, the first digit's a 1. So how many options do you have for that first digit? 1, not because it's a 1, but because it has to be just that one number. So it has to be a 1 there. It says the next 2 digits are letters. That does say that the letters O, I, and Q are not used. And I believe that's true for our license plate system because O's look like zeros and I's look like ones and Q's from a distance look like zeros. So they kind of avoid that. So how many letters if those can't be used? 23. So for the next 2 digits that are letters, I got to go, there's 23 options. So I have to have a number 1. There's 1 choice there. The next are letters, choice. The next are numbers. So in the numbers, how many options? 10. So 10, 10. And it says the last digit is a letter. So no I, again, nothing can be used. So if the last digit is a letter, another 23. Now, I made this problem up. Over the life of my teaching, I have seen those rules change and continue to change. It used to be 1 number, 2 letters, and then numbers. And then it was 1 number, 3 letters, and then numbers. And then now I start seeing stuff scramble up. And the reason why they added an additional letter, think about it. If I just changed that 10 to an option for a letter, and I just went, think about it. Instead of multiplying by 10, I'm multiplying by 23. That's significantly more, isn't it? Or if I let a space be a number or a letter, now I can change that to 33. I can get tons more license plates out of that. So, and I can still keep that. And if you go to like LA, where they have millions and millions of millions and millions of people in that area, there's really hardly any rhyme or reason to their stuff. You can see numbers and letters in every little space because it's like 33, 33, 33, 33, 33. And if you have that, you really can explode the number of license plates that you have in a different area. Now that's with replacement. With no replacement, the first thing has to be a what? It has to be a 1, right? It says the next one, and it says if I'm not replacing, then if I'm not replacing anything, then as soon as I pick that number, everything else is off the table, right? So right here with no replacement, here's my 7 digits. That has to be a 1, so there's 1 option, and 1 is off the table. The next have to be letters, but I can't use 0, I, or Q. So the next is 23, but what's the next after that? 22, and then the next after that? 9, why 9? Because I already used 1, and then the next after that? 8, and then 7, and then the very last one? 21. Are y'all seeing this? Because the fundamental counting principle says when you do multiple things, count the number of ways of each, multiply them together. And you're talking about this over and over and over. All right, permutations. Okay, I don't know if you remember permutations, but there are 2 big deals in calculus, not calculus, in probability that are permutations. A huge deal in what we're doing. All right, first thing, for permutations, okay? Permutations is a way to count, all right, when the order in which you're doing something has an effect on the outcome. Now, that gets messed up with you because of real life. Like, if you have a locker, on that locker you have a combination, right? Does the order in which you dial your 3 numbers have an effect on whether or not it opens? Yes, it's named wrong. That is not a locker combination. That is a locker permutation, okay? It's just named wrong. If it truly was a combination, then if your locker combination was like 0, 6, 24, then you could dial 0, 6, 24, or you could dial 24, 6, 0, or 0, 24, 6. Any possible order would be fine. It would still open. That's what a real combination is. But a permutation doesn't count those. It counts when the order in which you do something has an effect on the outcome. Say in the library, I got to arrange books on a shelf. Does the order in which I arrange those in the library actually have an effect on the outcome? Yeah, in a library it does, because I got to go look for it, right? The Dewey Decimal System. Y'all even learn this stuff anymore? I know libraries are kind of obsolete because you just Google everything or whatever, or do research online. But in the olden days, we had to learn about the Dewey Decimal System. You couldn't just randomly throw a book in the media center. You'd never find it, right? So they actually have, or the Library of Congress, right? They actually have an order to these. It's very specific. It's arranged by whether it's topic, fiction, nonfiction, whatever. You go through there and then it's got little decimal codes, whatever that Dewey Decimal System is. It would matter. Now, in your bedroom, does the order in which you arrange them have an effect on the outcome? No, if you got some books, you put them on a freaking shelf, right? Unless you're a little obsessive compulsive maybe, and you got to go from high to low or whatever, or by colors or by size or whatever. Maybe those things come into play. And if it did, then the order would have an effect to you, right? So when you're counting, as you're counting, if the order has an effect on the outcome, think permutation. Okay, now a permutation, when you write it, if you can see this, I'm starting with NPN. This is something like 6P6. This is like me saying this. How many ways can you arrange 6 books in the library where the order has an effect on the outcome, right? How many ways can you take the 6 books and arrange all 6 of them? Okay? And if I do that, the math of it is this. It's take this number right here and put it on the top, subtract the 2 numbers, put it on the bottom, simplify. And while we're at it, 0 factorial is 1, 1 factorial is 1. Does everybody else know about other factorials? So like 4 factorial is 4, 3, 2, 1. And you don't have to always write the 1. I mean, you could just say 4, 3, 2, right? But if it's 0 factorial, make sure you know that's a 1. All right? So this is like me saying, hey, I have 6 cards, right, to choose from, but I'm going to choose all 6 of them. Tell me how many different ways I could choose, how many different, or if the order had an effect on the outcome. Now, not a lot of card games, the order doesn't have an effect, does it? Like if I'm dealing your 6 cards, and I give all 6 of them, does he go 2 of clubs? Oh man, my hand's terrible. It doesn't matter that the 2 of clubs comes first, or that the ace of spades comes last, right? Because here you're going to pick up your cards and you're going to put them in whatever order you want, right? But what if you're playing war? You ever play war? So you're playing war, right? You're not allowed to look at it. If I throw up an ace and then you throw up a king, right? I win. And if I throw up a king and you throw up a queen, I win. And if I throw a queen and you throw a jack, I win. Right? But what if I had an ace and you throw a jack? You win. But what if you throw a king and I throw a queen and then I throw a king? So I had the same 3 cards, but I changed the order. I actually managed to win a hand, didn't I? So the order in which I did things did have an effect on the outcome. So some card games that would be true. But if you have to ask yourself that question. Is the order that in which I'm doing something, is it affected by the outcome? And if it is affected by the outcome, or if it does affect the outcome, you use a permutation. If it doesn't matter, if I'm saying, hey guys, you're playing poker, you're playing spades, you're playing hearts, here are your 6 cards or 8 cards or 10 cards, whatever, and you get your cards. If you're picking up those cards and you're like sorting them out, did the order in which you received them have an effect on your hand? Did the order make your hand any better or any less? And if it doesn't, that would be a combination. But if the order in which you receive them, if it depends, or the order in which you arrange them, if it makes a difference, order in which you dial your combination, which is really permutation, if it matters, well, then it's a permutation. So looking at situations like this, all you have to do for the math, take that first number, make it a factorial on the top, subtract them, put it on the bottom. Don't make the mistake of taking the first number on the top, the second number on the bottom. That doesn't happen. It's always first number on the top, the difference on the bottom. And then you just multiply it out. And you might even learn how to multiply in Tyree's class. Did y'all learn factorials and memorize them? If you happen to have those memorized, great. But remember, I'm only going to have you set it up. So when you set it up, you could write stuff like 6P3 and call it a day. Okay? So you're not going to have to do all the math so much. Maybe one little problem at the end. So check this out. How many permutations are possible, or I could say arrangements, or different ways to arrange the following letters? Well, think about it. How many letters do you have to arrange? 5. And you're arranging those 5. Does the order, write this, does the order in which you arrange them have an effect on the outcome? Yes, because it said permutation. So you could literally go, well, there are 5 to choose from. The order matters. Put the P in there. How many am I actually arranging? It says all 5. So there's 5 to pick from, but I'm arranging all 5. So 5 factorial, 5 minus 5. And remember, 0 factorial means 1. So 5, 4, 3, 2, 1 over 1, 120. Although you're fine to stop right here. Are you with me? Now, how about this? How many unique words can be formed from all the letters in the word count? How many letters do you have to choose from? 5? 5? Are you using all of them? It says, how many unique words can be formed from all the letters? So I'm using all of them. So 5P5. I'm good. Now, have you noticed that 5P5 or 4P4, whenever the numbers match, have you noticed it ends up being just 5 factorial? That's another way you could think about it. So I actually didn't skip anything today. So make sure you kind of play around with these. If you want to look a little bit ahead, you can. But we're just going to be plugging through this combination sheet over the next few days. We'll probably start picking it up a little bit. Y'all are a good one.